All right, I guess we'll get to it. Hello, Insentia. Welcome to the stream. We're working again on a short Odyssey today, as we always do. This is my game with a custom-made engine. And today, we're very much tracing in the footsteps of Crysis with our destroying some palm trees. We're destroying some palm trees today. We worked a little bit on that. I mean, we worked a lot on that last stream a couple days ago. But we're going to do even more palm tree destruction. As you can see, our boy Luis here has an axe. He's going to cut this guy down. We were working on the sound effects for it, and I think we're going to do a little bit more work on sound effects, and then we're going to maybe do some particles and stuff like that. But you can see it makes a sound when it hits the ground. Now, that's what we added the other day on Thursday when we were doing our stream. But there's kind of like a little bit of an issue, and that is that, like, no matter how violently this thing hits the ground, it makes the same sound, which is, I think it would add a lot if we... This guy's struggling to get up here. Let's kill this guy. Yeah, die. I think it would add a lot if we made the sounds... Exactly. Hatchet Gaming. If we made the sounds, like, change depending on how hard the thing hit the ground. So, right now, if we look at the, So, the way I actually have this set up is basically, there's this component that I've added to the tree. And actually, I'll explain it a little bit later, but it's not just to the tree. It's called impact sounds. And right now, there's only one sound and one threshold. So I think the idea is that I'm going to have you be able to have multiple slots in here, right? And then you can be like, oh, at this sound, like at this threshold, you do this sound, right? Like, but then if it's louder, because we can always make the sound louder, but there's actually a limit because we don't want to like blow people's ears out. So like, basically, I think we're going to have like sound at... I also did like a lot more research on physics and stuff in between the last couple days. Hola, welcome to the stream. I did a lot more research on like physics and stuff, and like realized about like how the mass and speed of moving objects translates into like the energy of a collision. So I think instead of having this threshold, I think this threshold is going to be based on energy now instead of like mass and stuff like that. So I also realized that there's no music here. Yeah, let's get the cool music here. So yeah, I think what we're gonna do is we're gonna make a snappier sound for a higher energy collision for this. And also I'll also explain that, so even if an object doesn't have this impact sound thing, it still is going to make an impact. I mean, the hatchet... Is the hatchet a good example? We'll see. So basically, the hatchet, as you can see, it doesn't have this impact sound, but it still makes a sound when it hits the ground. And the reason for that is because the terrain has an impact sound on it. So basically, any sound that like sorry, oh, that didn't mean to do that. Any object that doesn't have a that doesn't have its own impact sound is going to take its impact sound from the terrain, basically when it hits it. So, before we get to that, I do have soda today. It is Solo Apple J from the nation of Trinidad and Tobago. So what I assume is this is like basically apple juice mixed with soda water. If I remember what the Germans call it, Apfelschorle or something like that. Yeah, you guys taught me that on stream. So open that up. Yeah, I don't know. It's pretty good. Basically, it just tastes like apple juice that's carbonated. Pretty decent. We've had a similar drink on before. But I think what we're going to do now is I'm going to open up... I'm going to quit out of the game. I'm going to open up Reaper. I got to do some settings so that you can actually hear that. Or maybe that's already set up. Okay. 1 second. Just plug you guys into the Jack client here. And then, so this is the impact sound that I have set up. Afroschale, yeah. Okay, great. Hopefully I said that right. So basically, this is the thud that we're working with. But I want to add like some for the higher energy collision. I want to add like some snapping and like. Did you guys hear that? Like, that's like, for like, specifically the wood, I want to add like that sound into it. So, I'm going to copy that in here. And then we're going to kind of like figure out what we want that to be. So I'm going to find just the cracking sound that I want inside. Okay, so the cracking sound is actually just this initial part. So, like, kind of... Sorry, I gotta turn off the snapping here. Or, actually, I'm gonna set the tempo to, like, 200 or something like that. Just so that gives us more... Yeah, there we go. More snapping options. No? Did I... There we go. But anyway, let's just trim that to here. What does this sound like? Actually, I think it's the second part that I want. Right here. Yeah, that's what I want. Okay, so we're gonna kind of like layer these sounds in here, I think. That's kind of the idea. So I'm gonna copy this guy, put it here, and see what. So cut that out here, like just this first part here. So that's too loud. So I'm gonna bring this one down. Also, it's... I'm gonna take the EQ and I'm gonna take out the low end of this one. So it just kind of got the cracking. So this is... I think we can make it... Just move these around so it's more in sync this way. So... Yeah, so this is low energy, a little bit higher energy. It's got a little bit more top end crack into it. Also, I feel like we can speed this up. Because if it's... So right now it's playing back at half speed of what the actual recording is. But if I change it to like 0.6x, maybe that's more... And then I think... Yeah, I don't know about that actually, because we still want the low end rumble, right? So I think we need like an extra sound in there. Snap. What do we got here? Not playing? Okay. Ooh, I like that. Okay, that's just like, that's literally somebody eating an apple, I think. So I'm gonna open the folder. Gonna copy that into Reaper here. Whoopsies, meant to do that on a new track. So let's get that in here. Okay, so that's the part that I want. Like, really biting into that apple. That's starting to sound like what I want. Okay, so obviously this part of it is too loud, so we're gonna like bring it down. Also, is that clipping? Maybe a little bit. So, I'm gonna sort of... I mean, that definitely sounds higher energy, so this is like... See? So I still gotta bring this, I think, even more down. Yeah, okay. And also, let's take the EQ for this, and I'm gonna roll off some of the really high end. Like, just like the very top end here. And some of the low end too, probably. And so then we still got the low end from this guy. And maybe I'll actually make him lower end even. So let's even slow it down even more. 0.4. Because, like, I guess a bigger impact. Yeah, it's going to have a longer decay time too, right? Okay, so the only problem here is that we're clipping. So I'm just gonna turn down, can I turn down them all at once? Yeah, no, it's not gonna work. I guess we probably want a, ooh, what happens if we just, let's just throw a friggin' compressor on there. Yeah. Recomp. And as you can see, it just makes it like a little bit quieter, but it still retains like the essence of the sound, as it were. Do I need to increase the ratio? 6:1. There we go. Nice. And what does this? Also gonna just... Okay, that's a good... I think that's a good, a good version of that. I'm gonna... just to make the selection here easier. Okay, so... Then I'm gonna export this. I'm gonna render this. So, render as... it's gonna be called, tree crack. Tree... Sorry, or I'm gonna call it tree thud high energy. Yeah. Then I'm gonna go ahead and render that. Also, technically this should be mono. Oh, I didn't mean to do that. I meant to render just the selected part because it's an entire part. Time selection. There we go. Overwrite, yes. Okay, so there we go. We got our high energy crack there. Then we're gonna go back into the game and we're gonna start adding the extra features that we needed for basically having different thresholds at higher energy levels, basically. So we're gonna need some music while we work. So let's put some on. All right, so I have my impacts down here. Right now we have one sound and one threshold. So I think what we need to do is we need to make a std vector of thresholds. Oh, actually. Ooh, this is cool. We can use our friggin' structure of array thing. So we got SoaGen. Aha. Okay, this is SoaGen, a really cool library which lets you make basically parallel arrays. I'm just trying to remember how you use it because I did use it in okay, here we go. So basically these are our columns here of our table, and it's gonna take a, do we need to include SoaGen.h? Include SoaGen. Are you not giving me SoaGen.hpp? Cool. There we go. So basically, its columns are gonna be, it's gotta get a sound data and a threshold. Although the threshold's gonna be a float. And basically, and this is even called sounds. So this float is going to be basically like the energy level. And this sound data is going to be the sound that we play at that energy level, basically. So yeah. Wait 1 second. I'm just curious, is that, what's bigger, if we do that or 2 vectors of the same? I'm just curious what, like, so that is 24. Okay, so it's literally, so each one of these is 24 bytes, right? 24, 24, and the table is 48 bytes. So it's exactly the same, which is cool. Anyway, so basically we need to do a little bit of surgery here to our code. How do I have this? So, callback. Yeah, so here's our impact sound callback. There's probably gonna be some errors in here because we no longer have this parameter called threshold. Also, yeah, mass threshold, this is not. So, what we're gonna do is we're gonna calculate the energy, which is what we have here. And as per physics, the energy of the impact is basically the mass times the velocity squared. And basically, in this case, it's the velocity along the contact normal. And since it's velocity in one axis, we call that speed, right? Okay, so because this is a scalar quantity, Does your engine use any custom allocators? No, not really. I mean, like I use, nah, not really. Honestly, like, I think the thing with like custom allocators is like, you're better off just like not allocating than like doing all this work to like try to figure out like, ooh, how do I allocate more efficiently? It's just like, just don't do as many allocations is kind of my approach, right? I mean, we use these custom data structures, which do have, like, not a custom data structure. Somebody else made SoaGen. I'd like to plug SoaGen. It's a great library. You should check it out. Anyway, I think it uses custom allocators internally, but, like, I didn't need to write them, right? So, anyway. So, but yeah, just generally avoid allocating as much as possible. But in this case, for playing this sound, we're not doing any allocations at all. So, in this case, it doesn't matter. So, we are going to go for auto. And also, so these are we're gonna assume that this is ordered by sound, comma, threshold. We're gonna assume that this is ordered in increasing or decreasing order of threshold. I can put the highest threshold first, I think. I think that's what I want to do. In our impact sound dot sounds. So we're using our structured bindings here. This is gonna be our sound data, and this is gonna be our threshold, right? So basically, if our energy is greater than our threshold, we simply play the sound, and then we return. Yeah, okay. So, I'm just gonna try to... I'm thinking. Also, we need to move this up, I think. Actually... Yeah, that's fine. I might increase that to like 750 or something like that, but we'll see. So, if the energy is greater than the threshold, we're gonna want that sound. We're gonna want to play the sound, but, let me get rid of all this stuff here. Okay, so we got our hit sound here. Oop. And we gotta find our playback volume, which we calculate here. Okay. So if the energy is greater than our threshold, we are going to set the hit sound to the buffer, and then we are going to break out of this loop. Okay, cool. Yes, that makes sense. Hey, what's up? Hello, what's up? Name I can't pronounce. Welcome to the stream. We're making some, we're working on basically impact sounds. So we're destroying some palm trees, and we're trying to make it so that that we basically play a different sound depending on how violent the collision between two things is, right? And we're using this energy number here. Just call me HA Freeze. Thank you, that does make it easier. Okay, so it's gonna equal sound. So, and then, cool. Yeah, basically, also we can make it, if hit sound dot buffer. So basically, if we didn't find anything, we're just gonna return and not do any of this stuff. Like, basically, if we don't pass the threshold. Okay, cool. Now, we're gonna need to go into our... We're gonna need to do a little bit more stuff. We're gonna go into our editor. We're gonna find impact sound. basically, what we're going to want to do is we're going to want a, we're going to loop through basically this, here. And, yeah, this is going to basically create our, let's do a, put these on the same line here. Okay. Yeah, so basically we're going through IMGUI here, and then we're gonna need a button to like add a new sound. So IMGUI button, add new sound. And if we click on that, we're gonna do sounds dot pop back. Yeah. No, push back. Also, we're gonna put this after the list. And this is gonna be a remove last sound. Pop. Why can't you do that? Dot. Oh. I don't know. It was just being weird there. So that's gonna be dot in place back, I guess. Yeah. Okay, cool. And then I guess we need to give it a, sound data and a, float. Looks... Oh, that's some core gameplay at point. Looks awesome. Yeah, I mean, we'll go back into the game in just a second. Why is this giving me an error? Well, we'll see when we try to compile it. And then there's one last thing we need to do before we get back to the game. We gotta go into a JSON, serializer. So we got our impact sound. Here, we're going to append... we got to go through our list again. So we're going to copy this stuff. One second. Dot column. Okay. I'm gonna do this in two, Oh, actually, I think we can just do, oh, actually, we gotta do this whole thing again. I'm gonna copy, wait. Ah, here we go. I got my range with commas. Basically, yeah, I need to copy this. We got to write this out into JSON, basically. So this is going to be called thresholds. Then we gotta end our array. Then we're gonna copy this same thing with a comma in between. And that's gonna be called sounds. And that's gonna be this. Ooh, actually. Why is this giving me a, no vibe? Come on. What else does this want? Yeah, I think it's fine. Anyway, maybe it's just the, thing giving me grief here. Anyway, so, we need to basically now, append our, threshold here. And then here, we need to append our data. So now, that should be good for saving out our guy with the JSON, but how about loading him? What was that? How does that work if I, okay, so, we're gonna now find our impact sound again here. Okay, so there's more to, a little bit more to it than this. We need to, one moment. Yeah, so I guess this is where we load in the sounds. So I'm gonna do a std vector float thresholds. Then we're going to read in our thresholds. And then, one moment. There's this, then we're gonna take our sounds. We're going to resize yeah, let me rename that. Imp. We're gonna resize our sounds. Resize for overwrite, because we're gonna overwrite all of these with this. Also, this is gonna be an int here. And this is gonna be our sounds. So, one second. And then, okay, so we'll find our size, which is going to be auto size is equal to std min of thresholds dot size and sounds dot size, because like in case somehow these end up being the wrong size, we're just going to use the smaller one, because technically these arrays should be the same size, but if they're not, we're gonna just use the smaller one, so that we don't have any just like bad data, I guess. Okay, so then we're gonna resize it to size. Then we're gonna start loading in the data. So, I guess we can mem copy thresholds dot data into imp dot sounds dot column int and then the size is going to be dot is that, what does that return? One second, I'm gonna go to one moment. I just gotta see where I use this friggin' thing. Oh, this is by index. I guess I should do it by index. Maybe that's how I screwed up. Yeah. Column. Yeah. So, I think where I screwed up is that's actually column 1. Not column int. If that's... Because I could technically have multiple columns of... So that's column 1, and that's column 0. I guess. And is that the way I have it set up? Yeah, so column 0 is the... Okay, cool. Sorry, this is just taking a little bit longer than I thought. I'm trying to remember how to use this library. And then size times size of int. Okay. Cool. That's good. Then we're going to we're simply going to set our sound index to so column 0 at index I. I guess this is going to be for size ti equals 0. I is smaller than size plus I. Okay, cool. So then we're going to have sound index is going to equal sounds at I auto. Cool. That should almost do it. There's gonna be one more compilation thing that probably happens when we try to compile this, but... Okay, why is this happening? So, basically... range with commas, why are you complaining? It's not a range. Okay, let's see. Std span sound column is equal to or I guess we can just do that, column 0 dot data. Okay, why can't we do dot data? What do we have? Dot what? Dot. Huh? Column 0 dot. Maybe. It's a pointer, I guess. Okay. How would I have this set up in culling.h? Jaco, we got a crew tuned in today. What was the drink of choice today? It's Solo Apple J from the nation of Trinidad and Tobago. It's basically just carbonated apple juice. It's pretty good. Anyway, we got to figure out why. But yeah, thanks for tuning in. There. All right, so it's literally okay. So that's just a pointer to that, and then we have size. Or I guess that's just the whole guy dot size. Right, because the size is going to be the same. Okay, cool. That makes sense. So there's our range. And that should satisfy this concept here. And then we'll do... This is our threshold column. And this is going to be column 1. Now, that's probably going to have some more errors, but it's okay. Okay, so what are our errors today right now? No members. Okay, so that makes sense. This is straightforward now. So, this we can simply just loop through our sounds dot column 1. Do I have to do like a span? Yeah. Because I just want to loop over one of the columns. That sounds dot size. Cool. And then that's just gonna be sound. Why you, oh, it's just a, that's gotta be a, one of these. And then, that should, oh, column 0. There we go. Okay, one more, which is right here. And that we can just, yeah, I think that would do it. I think now we can get back into the game finally. And then we'll be able to set our different, like, impact sounds. Okay, actually, one more thing. I'm gonna uncomment that. Let's stop the build. And, oh, we failed anyway, so what was the issue? Basically, I want to get a impulse. I'm actually going to rewrite this with energy. What's impulse? Gonna get rid of impulse here, and that's gonna energy. Okay, what's the... Ah. Simple. Okay, and this guy, I think he's not an error, but I think Sea Lion is just getting confused. Or I suppose Clang D, because that's the back end for it, is getting confused. And thinks it's an error, but that's not an error. Alright. So, now we can recompile that. Hopefully that'll go. Yeah, so I was also, like, with all this, stuff about, like, energy and, like, friggin', impact, velocities and stuff like that, I was looking up, if I could, like, redo the way that I calculate, like, the bombs to be more, like, physically accurate. And I was doing some reading, and that brought me to, basically reading about how explosion physics work, which is definitely going to put me on some kind of list, for, like, investigation. This is a, this is, if, RCMP, if you're watching, just let you know, I'm not building a bomb. I'm trying to simulate one in a video game, just so you know. Okay, anyway. Yeah, so I still don't completely understand the physics of it, but basically I gotta do more reading about, like, the, Taylor von Neumann-Sadov blast wave, to, like, try to figure out, like, basically, like, at what distance, like, different pressures, happen from the explosion, right? Anyway. And once again, to any authorities that are watching, I'm not trying to build a bomb. Alright, here we go. Games here. So, if we go do this, everything should be broken because, there is no, there's not going to be... Oh, we already got... Oh, okay, so, this is already happening. We shouldn't be... Oh. That extra exclamation mark when we didn't need one. My bad. So, basically, we blew away all the, but I can actually just rewrite the JSON file here. So basically, we have our impact sound. This says sound 0, so I'm gonna make this sounds. It's gonna be a, list, or an array, and then we got our thresholds, and then that's gonna be, let's say 1. Yeah. This is the bent palm, and then we're gonna do the same thing for the... I mean, I can do this in the editor, but I'm waiting for the, I'm waiting for it to finish compiling. So while I'm doing that, I can just edit the JSON file. Sorry, I'm doing, palm stump here. Yeah, just gonna paste that in. So at threshold 1, it does that sound. And, I guess we also gotta go back to our terrain. We got our impact sound. We're gonna add a new sound, and, this is, messy. But anyway, thud, and at threshold 1. And then we're gonna save the game here. Okay, so, now, let's go back to, me here, and let's pull this out. And so that we can get in our louder. So that, what was that? What was our peak energy? Like 630 something. So I'm gonna go ahead and I'm gonna get our bent palm stump again. Bent Palm stump? Okay, yeah, bent palm stump. This is the one we just destroyed. Gonna select this guy. We're gonna add a new sound. Oh, we have a issue. We didn't. Okay, 1 second. We need to redo the UI for this. So I gotta do. We gotta make this like a table or something. Actually, no, that seems like that'd be. Oh, I know what we can do. We can just do IMGUI push ID and pop ID. So impact sound. So in here we'll just do IMGUI push ID. Do or ID, and then IMGUI pop ID? Yeah. And then we do ID++, then just go to the next one. Okay, cool. So that should solve that issue. Let's go back to it. Waiting to compile. I gotta make my compile times better. I keep talking that I'm gonna do that, but I haven't got around to it. There's just so much other shit I'm working on. Like, personally, I don't mind the compile time, because, like, I'm usually, like, trying to think about other things. Like, I'm usually trying to, like, think through problems while this is happening. But I understand, like, for chat, it might not be, or for the people watching, it might not be that entertaining, right? So, yeah, like, I think people largely overestimate, like... I mean, if your compile time is, like, really bad, which I have been in situations on other projects where compile time is, like, really bad, where it's, like, legitimately, like, a huge problem. But in this case, I feel like it's mostly just a problem for the audience. Alright, let's get back to it. So, yeah, so we'll take our bent palm again. So, bent palm stump. And we'll take this guy. And the impact sound, we're going to add a new sound, see that? And then we're going to need to go into our sounds. We're going to need to go into our tree thud high energy. And I'll put the threshold for this at 500. And that's measured in joules. So 500 joules is going to make this guy make a louder sound. So we select the parent. We save that prefab. Now, so that fell with a energy of, I can't see because there's too much readouts going on here. But it eventually settles down. I should increase the threshold so that it... Oh, why didn't that fire? Interesting. Let's try that again. So let's just drop it. That didn't fire. Why not? Oh. Somehow that didn't save. So let's go into our JSON and see what came out here. Ooh, that's a problem. We have some garbage being written into here. So clearly our saving is not working correctly. So what it should be is it should be 0 and 1, right? If we manually do that, but something's going on with our impact sound. So let's impact sound. So this is when we write it in that is the problem. So, okay, well that makes sense. We need to actually get sound index. So it's appending the data directly, but what we want to do is this is our data, and then we want to get the index of that data. That's the problem. So we can redo this, and hopefully that should fix it. Yeah. So, let's get music back on. Whew. Just waiting for the compilation again. I think it's these two files, editor and JSON serializer, which are massive files and they need to be broken down. And I think that would improve the compilation speed a lot, basically. Because, like, this file, how many lines is it? It's 3,486 lines, which is... It doesn't seem like that much. I mean, it might sound like a lot to some, but when you consider that a lot of it is macros that basically get expanded to like this insane shit, it actually is a lot. So let's get that open here. Okay, so now let's try to see what happens if we chop down that tree. Yeah, I mean, we're not gonna see it, so. Okay, so that hit the energy with a peak 39. That should have triggered the second one, but what do we have here? We got our impact sound, tree thud high energy. Yeah, 39. So let's see. Let's bring it up. That should have hit the second one. But maybe it isn't, I'm just not hearing it correctly. So that's let's look at this and see, is it, so you have we go through all our sounds. Oh my god, I totally did it. I need to, the problem is that these are in the wrong order. So, I need to make sure that they are sorted in order from least to greatest. So I mean, right now I'm just gonna do that manually. Let's just swap the order. Make that 2 actually. Just to cut down on some of the, or make that 4. Then, oh shit, I need to create a new one actually to do that with, because if I save this one, it's gonna break the whole initial positioning of it. So I need to get my bent palm stump, take this, swap the order of these things around. Tree thud high energy, tree thud, save prefab, and now we can go into our JSON file and make sure that it got saved correct. Is that? Oh shit! Whoopsies. 1 second. Remove component. Prefab child. Select. Save prefab. Save prefab of this one. So now I go here, do that. Is everything saved correctly? It looks like it is. It looks like it is. So Treat that high energy, entry thud. So now, there we go. So this is a soft thud. No, that was a hard thud. But okay. Okay, so that's the hard thud I want, but where's the soft thud? Okay, that was a soft thud. So maybe just the... Maybe 500. Maybe it needs to be like 1,000. So that's a... 2,000. So I want this to be a... Okay, that's a soft thud. That's a hard thud. Does that kind of make sense? So 3,000, let's say. So soft thud, hard thud. Okay, I'm gonna do. So 2,500 is gonna be the final one. So, basically, 2,500. Select, save prefab. And now I'm going to do the same thing with the palm stump, just this one. I'm going to do add a new sound. This has got to be our high energy one. This is going to be a thud, and this is going to be 2,500. Save prefab. Now, what happens when I hit this guy? Oh. Yeah, okay, so basically now it's making a more interesting sound. That's good. That's good. And so I can... Okay, so there's one more thing I gotta do. I gotta find the terrain. I'm gonna take terrain, and I gotta fix the thud on that one. It's not gonna have the high impact sound. We're just gonna do the regular one. I'm gonna make this a thud, and I'm gonna give the impact 4, and we're gonna save that. Oh shit! I didn't mean to save the prefab. I meant to save the. You can't save a terrain prefab. It's just broken. It's just I just haven't like implemented that. So I'm gonna take that, gonna go my terrain one more time. So terrain, find the impact sound, gonna add a new sound, gonna set it to thud. Gonna set the energy threshold to 4, and then I'm gonna hit this save button, not that save button. I realize the UX on that is not great. So now every little thing should cause some kind of thud, right? Maybe not. Maybe the threshold's too high. Oh, because it has an impact sound. It has its own impact sound. So I'm going to remove this. I'm going to remove the impact sound. And then we'll see. Oh. Ooh, geez. Can't do that. Okay. a little bit of stuff going on here. Yeah, I think that's a problem. That's a problem. Okay. The way the editors are working is not, so I'm just going to manually go into, barrel.json, and I'm just gonna remove the impact sound. Impact sound, you can go away. Now, I mean, the barrel might have its own impact sound, that we need to do, but like, now I'm gonna find this guy. He no longer has the impact sound, so when I drop him, he should trigger the terrain's impact sound, because he doesn't have his own, and it should make a sound. There we go. And if we do a thing, That's fine. Okay, great. Great. Yeah, it makes a slightly different sound. But anyway, this is the reason why it's called Crysis 4. Why the stream is called Crysis 4 today. Because we're destroying palm trees, basically. Now, there's like one more thing I want to do. I want to have some... I feel like it should like kick up some dust and shit. Which would make it, I think, look a lot cooler. And the way we're going to do that is we're going to add another component. So we're going to go back to C++ in just a second. But it's going to... this component should be quite a bit easier because it doesn't involve sounds and stuff like that. And we don't need to do the whole... whatchamacallit? I don't know. The whole custom JSON saving. Like, it should be like, we should just be able to do like a really simple saving in JSON. So, what I'm gonna do is I'm gonna put on the music, and we're gonna add this to the terrain. It's just gonna be on the terrain. We're gonna make the terrain basically pop up different particles when something hits the ground. So, we're gonna go to... Actually, maybe we should just use the existing terrain component, just for like brevity. So, we're gonna go to setup objects. Then we're gonna go to the definition here. We're basically gonna need to hook up a new callback, for terrain. So, okay, that's actually gonna be setup physics object. Oh, wait, one second. Callbacks. Yes. Okay, so, we're gonna do this. Is called, setup terrain particle callbacks. And this is gonna go through terrain. Or I guess it's gonna be called, I guess it was called height map, technically. So, terrain and transform. Actually, you know what? We already... no, I'm gonna undo that. I guess this is after... Okay, cool. So... Oh, this is character damage callbacks. So we need to get the physics object from the terrain. This is gonna get the physics object for the terrain. We're gonna place a new contact callback, and this is gonna be terrain contact callback. And this is gonna make particles pop out. So we obviously haven't defined this, but we will. So I'm gonna make this terrain contact just to make it clear that this is what it is. So yeah, right after her, I'm gonna, and this is gonna have the same signature as this. So basically we're gonna make the terrain pop up particles going in the direction of, I guess, up. I mean, I guess in the direction of the contact normal, actually. That would make sense. So we can ignore most of this stuff, but I'm going to take the energy calculation that we do here. And so we got to find our mass, and the way we do that is, I guess it's going to be the other. So other, in this case, because it's terrain, and terrain is a static, we know that the other guy is a, is going to be a dynamic object, like a rigid body or something like that. So we're going to do ev.other.getMass, and then we're going to also assert that ev.other is a rigid body. Dot is rigid body. And then we're going to do if our energy is greater than, like, I don't know, let's say 10. We are going to add a dust particle. We're going to make this more complicated in a minute, but, like, I just want to see if this works. So dust particles dot add the position is going to be ev dot position. So the, like, the contact event. Is my camera frozen? No, it's not frozen. Okay, sorry. I thought for a second it was. So at our ev dot position, in the direction, or the velocity, is going to be ev dot normal. So this is like the contact normal, like the direction perpendicular to the like ground. So multiplied by, let's say, energy. So like obviously it's gonna go faster depending on the energy that hits the ground. And then we're gonna do rotation is gonna be random, I guess. Auto rotation is equal to random angle radians. Awesome. So yeah. So let's see what happens. Like scaling the energy, like, I guess we have to like do like impulse or whatever. Like we gotta figure out like what the, but this is like just, it's all vibes, man. I mean, we should do proper physics though. We should try. We should try. There's no vibes in the code. We're not vibe coding. We're real coding. Because we don't fuck with that shit. But like, the vibes are in my head. Yeah. So theoretically, this should make a dust particle pop up when something hits the ground. All right, let's try that. So, let's see what happens. I didn't see any particles. Maybe. So let's try with something simpler and do something that's not in the tall grass, so it might be. Are we actually getting that? Are we actually getting activated here? Let's put a breakpoint in that. Oh! Okay. It is getting activated. What's the normal? What's the contact normal? Oh! I see. Okay, so when... Okay. The contact normal is actually going in. We want it to pop out. That's the problem. Okay, so, yeah. So I think the problem is it's just going backwards. Like, the particle's going backwards, so we don't see it. Basically. Because I saw that, like, the y was -1, which is, like, you know, or negative. It was a negative number. Like, the y should be a positive number, makes it go up. Basically. And then we could do something interesting. We could see if the impact is happening in the grass, and then we could do like a grass particle. So, I think we're gonna need to do. Let's just do this real quickly. Let's create a particle cloud of grass particles. And so then, because we already have our grass texture, so we could try that. Like, where's our grass textures? Is it in textures or is it in models? I mean, we'll see in a second. Let's get the 1 second. Oh, tall grass. This is where it is. Yeah. Oh, which is the one we actually use? It must be this one? I mean, we'll see. We'll see in a second. Okay, so we're waiting for this. We're waiting for this. All right, need that. All right, let's get into the game here. Let's grab our sword. Let's cut down a tree. And then let's see what happens. Oh, well, we got it. We got a particle for something landing on it. Let's try this guy. Okay, I saw a particle, so something's happening. Okay, maybe a little bit too aggressive. Maybe a bit too aggressive, because it's really popping off there. That's funny. Let's try that again. That's funny. Okay, so that's gonna eventually settle down. Yeah, we had it just when we were running. That's kind of interesting. I mean, a little bit, like... What happens if I roll? Let's try. Sorry, let's wait for our stamina to... And then we'll roll. No, we didn't get a... I mean, it would be cool if we got, like, some dust when we were rolling. Ah! Okay, so we're randomly getting it. I think. It seems like a little bit finicky, but... Okay, so what's this? That didn't seem to create one. 28, it should have triggered it. Also, that's not creating a sound. Why is that not creating a sound? Anyway, I'm gonna put our dust particles. Oh, here. Let's put a breakpoint in there again. Like, so what happens if I drop this guy? Oh, it's hitting. What's the normal? Yeah, okay, that's let's keep I'm gonna keep stepping forward and seeing what happens here. We're getting a lot of that, so... Oh, whoa, that made it happen. Okay, that's happening. Okay, interesting. Oh, it might be, like, the number of particles that have already been spawned or something like that. Anyway, the threshold probably needs to be higher. I mean... Or at least the... Okay, so that was 4,000. That seems like that should have been over the threshold. So... Seems... Oh, I guess it's just the velocity's too high. It's so fast we don't even see it. That makes sense. So... So the energy is... So what if Because, like, the energy is, like, velocity squared, right? But, like, what would the impulse on the particle be? Right? So, I'm just thinking for a minute, like, what would we do here? I mean, I guess we could just add some like, maximum... Like, we could add, like, energy... Let's do energy over 1,000. Right? And then do, like, min... just so that, like, there's, like, some maximum speed that they could be moving at. Let's say 10 meters per second. Oh, but then... Okay, wait, no, okay, that makes sense. Okay, so let's try that. That should be more consistent, at least. The other thing is that they're moving exactly at the contact normal. So I think what we're going to want to do is we're going to want to rotate, or we're going to want to, like, add a little bit of horizontal motion just randomly. So, we'll do auto horizontal equals co-random normal point. So this is gonna be like a normally distributed like, yeah, this is okay, cool, 1 second. Or I mean, I guess we could just add just a random, like, offset to it. So, sorry, let's mute the stuff here. So, let's drop that shit again. Ah, nice. Okay, so that's interesting. Okay, that's pretty good, actually. That's much better. So, now we can add some randomness. I think that's what we need to do. One moment. Yeah. Yeah, we're gonna take this and we're gonna add some randomness to the dust particles. And also, I think we're gonna get the grass involved as well, right? So I'm gonna quit this. Gonna do that. So I'm gonna do 1 second. Let's get the so we get velocity randomness. So basically what I'm gonna do is I'm gonna do the normal. We're gonna do the normal plus the velocity randomness. So the normal times 0.9 and the velocity randomness times 0.1. So basically, we'll do like 20%, like, sorry, let's do 20% random. 20% random, 80% directional, I think. And then that's gonna maybe do like a more interesting pattern of particles. Also, what I'm gonna do is I'm gonna do for size t. I'm gonna do like more than one particle. Also, this I equals 0. I is smaller than this can be this can be based on the energy as well. So like a small amount of energy will make a small amount of particles, and a large amount of energy. So this is gonna be float energy level. equals that. So, yeah, so this is gonna be clamp energy level is gonna be clamped between 1, so there's gonna be minimum 1 particle and maximum 100 particles, let's say. And then we'll do, yeah, plus I. So basically this is gonna run the whole thing, add a bunch of random particles at the impact site. Sorry, I forgot to check what my grass texture was actually being used in the game. So yeah, just waiting for that to... I think we finished our... Yeah, drink's empty. Alright. Compiling. Yeah, Game World is probably another one of those files that's too big, needs to be cut down, includes too many different things, which kind of makes sense because there's a lot going on here, but... Alright. Let's take this. Oh, I guess we were trying with the barrel. We were doing it with the barrel. So, barrel. Let's do like a soft one, like a little... Oh, that was just a tiny bit, and then like a lot. Eh, that's actually pretty cool. So a little bit. And then a lot. Not bad. Not bad, I think. So. That's kind of interesting. Okay, so I think we want to get the grass involved here. We want to figure out, like, is it falling on grass or is it falling on something else? So, there's a function that I have that I already am using to get the grass height at a specific location. So, yeah, I think this is basically working. So I want to go into my terrain. I'm going to find out... What was the actual image that I'm using here? Map source, terrain. Oh, it's not frig. Oh, grass material is material 20. So if I go to my materials, material editor, go to material 20. This is this one here, grass color 4k.png. So. We're gonna go into our guy here. We're gonna find our where I was. Okay, so dust particles. So we got our grass particles here. So we want to make grass particles are equal to basically the same thing as dust particles. I'm gonna say, like literally just gonna copy everything we have for dust particles. And I'm gonna make it grass particles. Grass particles. And then here we add grass particles. Okay, so now we have our grass particles. We need to actually give them the texture. This is gonna be called grass text. Which isn't defined, so we need to define it. So now we copy this. Where do we do dust text? Okay, so grass text is going to be equal to, one moment, get ref, we're getting, I'm gonna do, one second, I just need to add this extra parameter here to do something real quick. So, append path we need to set to false, which is what we've just done. there, and then I need to do this, which is this guy. No, this guy. Color 4K. Yeah, plant 002. I wish I could copy paste from here, but I didn't implement that. So we'll do resources / meshes. It should be in the texture folder, but it's in the mesh folder. So / meshes / tallgrass / this guy. Color 4K.png. So now we'll take our where we add our dust particles, which is callback. Okay, so we need to find at our position. So our position is ev.position. So we need to get the terrain component. So we're gonna do we're going to find our self, which we do this way. Then we need to do height map. We also need to get world from physics. Physics get world here. Great. Okay, so then we do terrain dot get grass. Wait. 1 second. maybe I needed to. Oh, it's this function here. Get grass height. So I need to actually move this up. Yeah. To here. So we call get grass height at position, and this is a world position. So we do get grass height terrain at our ev.position. And then we'll do why is that? It needs to be a address. Yeah. Okay. So auto grass height equals, and then we'll do if grass height, let's say greater than 0.25. Oh, actually, here we go. This could be cool. This could be cool. Yeah, let's do the simple one. Grass height is greater than 0.25. We will add. Okay, so we'll do auto particles equal, and this is gonna be a reference here. So reference to the particles equal to grass height is greater than 0.25 question mark. We will do grass particles. Otherwise, we will do dust particles, and we will add 2 particles here. And now we can recompile this, and that hopefully now we will get grass on the grass and a dust on everywhere else, basically. So yeah. So yeah, we're just waiting for that shit to compile. Yeah. And in the meantime, I need to edit these, actually, I don't need to edit this guy. This guy's fine. We actually don't need these impact sounds in a lot of places that I added them, because it should be handled by the terrain now. And we can get rid of that guy. Yeah. Cool. 1 second. Okay, so let's get back to the game here. Mute our guy here. Okay, so now if we drop this guy, so there was okay, the grass height's pretty low there, but if we drop this guy in the tall grass, what happens? Let's move a little bit closer to him. There we go. We got some grass particles. They don't look great, but Maybe too many of them. And rotated all weird. What's going on here? You guys see that? Okay, what's going on with the transparency here? Yeah, they're all looking funky with this shape here. Is it being loaded? Weird. Is the texture format odd? Because I feel like it should... Also, there's these weird cutoffs here. So... Oh, no, okay, so that's actually... We're just getting, like... Why is that, like, thresholded? I'm gonna look at the code here. Not this code. I mean, that's arguably not code. That's JSON files. Okay, so... I guess it's the grass particles where we set them up. Okay, so... Well, it's got a normal. We actually shouldn't have a normal map there. What happens if I use null pointer? I mean, that... It's flat, right? Oh, I guess it does have a normal map. It's these ones. So, I'm gonna copy that, actually. We're gonna have to call that grass normals. And we need to load grass normals. And then we'll copy this. And we will set that to red green. Okay, you clamp to generate maps. And then we also need to define our grass normals up here. Can I not just jump to the definition? No? You don't like me doing that? Oh, it just took a second. Okay, so we'll just do that. And now we should have some normal maps for our grass, but I mean, that might clean it up a little bit. But the transparency seems funky. I think that's... I'm gonna take a look at that in GIMP. Yeah. It just seems a little odd. Colors, levels. We're gonna look in levels here. And we're gonna go to alpha. Interesting. I don't know if that really tells us anything. Yeah, so there's those lines we were talking about before. The thing is, why are we seeing them? I guess it could be the compression making them pop up. But then, again, we do them... Unless we're using a different... we are using a different compression method. So that's actually probably it. Yeah, maybe that's it. Yeah. I have to explain it in a second, but we're just gonna see what this looks like. I mean, I'm thinking we should probably have a different, like, image for the grass particles, even though, like, technically we could use the ones that are on the grass, but, like, what does this look like? Oh, let's try this guy, because he's gonna look better, I think. Okay. Yeah. You see it, but I think we got to use some different looking particles, like ones that rotate better, that don't have like a flat edge on them. So, I guess we're gonna make some grass particles right now. It might. So I'm gonna take. I'm gonna see if our Kenny particle pack has anything that might be useful for that. So. I mean, It's got some dirt. This kind of looks like grass. I'm gonna go back to, we're gonna go to Kenny's website and see what else he has for us that we might be able to use. So this is the particle pack. We'll do VFX. Ooh, okay, there we go. Foliage sprites. Although, yeah, none of them are kind of like floating, you know what I mean? I want some like floating grass blades. So let's go back here. Light masks, what does he have? He's got like some, I don't know. I don't know about that. I don't know about that. What's this? Oh, some explosions. So yeah, I'm just gonna use this guy for now. Might need to make my own in a little bit, but I think that'll do for now. So we're gonna go into our textures. Chat's being real quiet, eh? Maybe I'm moving too. Maybe I'm being too brainy right now. But usually they have a lot to say. Interesting. Where's my? Sorry, I lost my window here when I opened up. When I opened up Kenny there. Anyway, let's close that out. So I'll go into my release folder here. Go into resources, textures. Scratch 01. Okay, cool. So I'm gonna actually delete grass normals because I'm not gonna use normals here. So we get grass particles, and we got grass text. So this is gonna be, I think we can go ahead and do that. It'll complain if we can't. And we get rid of this. And we're gonna use, I think it's scratch 01. Yeah. .png, and you're gonna say, why? How is this gonna work? It's not green. It's not green. Hey Tutu, nice to see ya. We're working on some particles. We need to make them green. So basically the way we do that is to take our grass particles and we tint. We're gonna set that to it's all right. Nice to see ya. We're making some particles that happen when things hit the ground in the tall grass. So our grass particle tint is going to be a Vec3. Yeah. And it's going to be green. So that's going to be, I don't know, let's do 0.1. 0. This is green, so let's do 0.9. It might be a funky grass color. And then blue, let's do 0.5. I don't know, I'm just pulling these numbers out of my ass here. But let's see what happens now when we compile that. Yeah, it is a little disappointing that that the flag emojis don't show on. I mean, maybe they do actually. I don't know. I don't know if the chat will. Why can't I do that? What do you mean it can't bind to an R value of that? Maybe I have to like manually construct it. You just typed it out. Okay, yeah. Do you gotta make me do the whole thing? Oh, I can't spell. Intrusive. Okay, so that... Let me just... Oh, I can't... It should work. I should just be able to put in no pointer there. Why can't I do that? Non-const reference L value to type. Oh, it's an R value. What's going on here? Oh, because it's not... Oh. Maybe. Maybe. I should totally make a const. That's... Or take it by value or something like that. So, So I think the problem is literally just that this should be const? Can I do that? Can I make it const? Is that allowed? Because it's not a pointer to a const t, it's a const pointer. We'll see if they let that in. If they let me do that. If you're wondering what intrusive pointer is, it's basically like shared pointer, but a little bit more efficient. Yeah. Because it basically stores the pointer, it does like one allocation instead of two, basically, every time you introduce one. Is that going? Alright, well, it doesn't seem to be giving me the error, but it probably is having to recompile more files now. You should have just called it shared pointer too. Yeah, maybe. It's called intrusive pointer because it like actually modifies, like it basically creates a derived type of your data and puts the control block right next to it, right? So like it also, there's one fewer indirection also accessing the pointer, right? If that makes sense. And also, or sorry, it's not there's one fewer indirection. It doesn't need to store the pointer, and because I believe if you look at size of shared pointer, a shared pointer is actually twice as big as a regular pointer, but an intrusive pointer is the same size, because basically in order to avoid having a second indirection, shared pointer basically puts both the pointer and the pointer to the control block in the shared pointer, right? So yeah, it's a little bit more efficient. Okay, what do we having issues here with? You're giving me problems. Oh. It doesn't like that I am doing a no pointer here. So why doesn't it like that? Oh. Okay, right. It's right here. Oh. File name. Why is this happening now? Let's go into debug mode and see what the hell's going on. I think it might just be crashing out in the wrong place. I was just trying to make something const. That's the way she goes in C++, am I right? What's going on with this? See, it's 4 o'clock almost, but I'm gonna keep going. I'm gonna keep going a little bit later, but we're gonna go at least like probably another half hour or something like that. I was gonna say you should like and subscribe if you're enjoying this, because I do more of this every week, twice a week. I do this on Saturdays and on Thursday, 2 p.m. on Saturday and 11 a.m. on Thursday, Eastern Standard Time, both of them, by the way. And yeah, you should subscribe and like the video as well, because that's helpful to me while I debug this. Okay, so, we're having some issues reading this JSON file, I guess. Let me take a look at something. Which JSON file is this? Did I corrupt the JSON file? The map? Ooh, that's not great. Let's look at the map. We probably have some like malformed JSON somewhere, which is causing this. But where? Okay, let's try that one more time. What are we loading that's causing issues? So, oh, it's a PNG. What's the PNG? Location. Is it this? It's this new... Okay. I think I ran into this before. I think Kenny's PNGs are like encoded in like a really weird way. So I'm going to open those with GIMP. And I'm literally just going to use GIMP and I'm going to save the file again. Yeah. So I'm going to go ahead and just overwrite that. Also, wait, I'm going to do a little bit more. I'm going to export it as a actual black and white PNG. Gray, here we go. And now, I'm going to reload it and see what happens. Also, I'm going to change the format to grayscale, because it is grayscale. Just to save ourselves a little bit of GPU memory there. Always good to save GPU memory and memory bandwidth. Memory bandwidth is crucial for good performance, especially when you're dealing with like particles and stuff like that, which can eat up a lot of it because there's gonna be a lot of overdraw, right? So, there we go. That's done. Let's mute that now. Okay, let's get into the game. Is it gonna crash? Or are we just gonna sail through because we fixed Kenny's... Yeah, Kenny was just giving us bunk PNGs, man. Come on, Kenny. I mean, we love you, but like, I gotta figure out what the hell's going on with his PNGs, because my PNG loader does not like them. Okay, so let's see what happens. Is this gonna work? Is this gonna just drop? Nice. That's kind of a weird green color. Also, we're getting that weird... Do you see what I'm talking about here? Oh, I mean, also... Wait. Yeah, this is not being interpreted correctly. Yeah. Because we're using the alpha, but there is no alpha. Because this is... One moment. Let's use a different PNG. Let's use... let's go back to our Kenny's pack here. He's got some other versions of them. Yeah, so we're going to go into... Kenny, where are you? Where did your files go to? Are they in documents? No, downloads. They're in downloads. Okay, Kenny particle pack. And we're going to go to the transparent PNG. We're going to copy this one. And also, we're going to bring that back to our sRGB. And then we're going to go into our textures folder. So let's get the... resources, textures. I'm gonna overwrite that guy. Hopefully the PNGs aren't weird again. I'll try that one more time. Hopefully the grass texture is gonna be like less weird. So, where's our barrel? There's our barrel. We'll drop the barrel into the tall grass here and see what pops up. Oh. Being a bit laggy from debug mode. Okay. I mean, this might be a bug I'll have to look in off stream, but the transparency still seems a little funky. You know what I'm saying? Like, it's not... So I might need to just deal with that image separate. Like, there's a little bit of a fringe on that. You know what I'm saying? You know what I'm saying? So I might need to tweak that. Also, there's... But one thing we could do is we could change the green color. There needs to be a little bit more red in that one. So, we're going to go back to release mode. We're going to find our... We're going to set the grass particle color to have, like, you know, 40% red in there. Just to make it, like, a more reasonable thing. But it does seem to be, like, more or less... Like, I mean, we're getting particles. So, I mean... You know, in a little bit, let's see what happens when we drop... when we drop one of the bosses. See what kind of... Ooh, this is going to look really cool with Leviathan, actually. I'm going to show you that in a second. Because now he's going to have the... When he hits the ground, he's going to have the impact sounds and the particles. You know what I'm saying? Know what I'm saying? Know what I'm saying? So that's going. Okay, cool. So, let's grab the guy here. Well, I mean, we don't need sword. Let's just grab this guy. And let's drop him in here. Okay, the color's a little bit better, but, like, still... The particle looks funky. You know what I'm saying? Oh, it's the opacity is weird. The opacity is looking weird, because the opacity should be basically full, right? We should basically have full opacity on these guys. So, opacity is going to equal 1. That might change things a little bit. We'll let a little bit more red, 0.5, and more green as well, 0.95. I think technically this should be in the sRGB color space, but actually, here's what we can do. I'm gonna like try to just duplicate this, just literally copy the color. So, what do we have here? GIMP has, is this out of 100? So, I'm gonna do, sorry, we need music. Where's my music? Yeah. You take a color picker, we're gonna do 0.35 point. Is that really what it is? RGB 0.35, 0.35. Hmm. Uh, 0.35, 0.35, and 0.14? That doesn't seem right. Let's try this guy right here. Seems like it should be more green than red. Okay, so 0.34, 0.36. And then the blue is 0.14. And then we're gonna take this and we're gonna do image sRGB? Can I, you gonna give me, why aren't you giving me my options here? Come on, Sea Lion. The image. Do I need to go to my friggin' image.h here and like manually type that in? Linear to sRGB to linear. Where were my suggestions, Sea Lion? Now they're here. Okay, so anyway, that should clean up the color a little bit. And then the opacity is full. I'm gonna go to my particle shader. Particle. How do I deal with the... Okay, so we have our alpha here. I'm kind of wondering if this has anything to do with it. Like... Alright, so mute that. Let's go to our particles over here. Our grass particles or whatever. Where are they? Oh, we had them. They were just... What do they look like? It's a little funky still. Sorry, let's just make them go like... Oh, that's the dust particles look great, I think. It's the grass particles that have an issue. Yeah, I don't know what this fringe is from. Like, you kind of get what they're supposed to look like. I'm just gonna have to deal with that later, I guess. Because is the image format not actually using alpha? Like... It's coming in as if it's actually not getting the alpha texture, right? That's the weird thing. Do I need to go into Nsight and see what format they're actually in? So sRGBA, yes. So it uses alpha. It should have an alpha in there. It should use a DXT5 or whatever. So I think we might need to open Nsight and see what the hell's going on. So that's what we're gonna do. But okay, NVIDIA Nsight. Unfortunately, nobody has a better debugger than NVIDIA. I still prefer Nsight to RenderDoc, even though I hate NVIDIA. It's just it just makes so much more sense to me. And also, like, I find it's just a way more usable program. Like, I find RenderDoc seems to, like, lag out a lot. Whereas, because RenderDoc is basically running your entire frame twice, which, I mean, Nsight might be doing, but for some reason, Nsight just feels, like, way better to use, in my opinion. Even though NVIDIA is evil and I hate them. Alright, there we go. So we got our thing. We're gonna capture the frame. Where's, Nsight? I hope OBS isn't mining this. I hope this is coming in fine. Capture for live analysis. Alright, so let's look to where the particles actually get drawn, which is somewhere here. Wait, where? Oh, yeah, draw particles. So, what's going on here? This is just the wireframe. So, where's my rendered color particles? Right here. So we're gonna find our fragment shader. We're looking for, it's probably gonna be the last one. No, it's not the last one. It's the, because this is the basically the whatchamacallit, the sparkles. So this is the waterfall. This is our flames. This is probably the smoke, yeah. This is fire again. The smoke. Fire. Smoke. Where's our actual guys here? Our grass. Here's the grass. It is! It's coming in the wrong texture. Do I need to, like, manually delete it? And then make it... So this is supposed to... It's the wrong texture format. This is the wrong texture format. That's why it's fucked up. So, terminate. I'm going to go into my ASO release... Optimize resources, textures. Find my Scratch 01, delete that. And then we're gonna rerun that. It's gonna regenerate the image, and hopefully it'll regenerate it with the right format. It might be just because I changed this in code and it didn't, oh. This is, we're friggin' up. Is this a Kenny problem? All right. Let's go into our, cancel, open recent, Scratch, this one. So I'm going to save as, no, export as, like, just, we're doing RGBA. Yeah, I'm thinking what's happening is maybe it's coming in as gray plus alpha, which might be screwing it up. So let's go in there and let's try one more time. Hopefully that weird fringe is gonna be gone. Okay, so. Oh, that looked... Yeah, there we go. Finally. We got our grass. It looks a little funny. It should probably be smaller. But... there we go. I mean, one way we could make it smaller is we literally just set size to be smaller. So, particles. Sorry, it's in... it's game world, actually. So. We can set our grass particles. Grass particles dot scale are going to be equal to 0.2. That should look a little bit better. Yeah. There we go. I'm just thinking, like, different things I could do here. We almost done compiling. There we go. There we go. Coming in hot. All right, let's play Crysis 4. Happening right now. All right. So, you gonna make some grass particles? What are they gonna look like? Oh, they're just small. Maybe they need to come in with, like, more velocity. Oh, that one didn't trigger. So, we're having an issue where sometimes the sound isn't always triggering. I mean, that looked alright. Yeah, these guys are moving... Okay, that looked pretty good, right? That's kind of cool, right? I might have to just, like, kind of, like, tweak around particle size and everything. But anyway, we're gonna go check out... ooh, let's see what happens if we take Behemoth. We're gonna need to spawn his, Behemoth Ragdoll. We're gonna plop him in here. I'm gonna go right up to him, and we're gonna see what happens with the, Okay, weird. Only his hands did it. Let's... Come on. So he is getting some dust. Let's try that again closer. Yeah, it could be that the things are happening, but they're not. Like if we... I think we are actually... They are actually coming in. Like if we go into wireframe mode and we do that again. Yeah, oh, they're getting spawned in, but they're just going down. It's like the contact normal is wrong. That's interesting. Why is that the case? Oh, I think I know why. There's an issue with terrain contact normal. Okay, so okay. We're gonna fix something here. So physics.cpp, there's a thing going on here. And I think this could be... So, there's this thing I had to hack... Although this is... What if... Like, I think we're getting backwards normals here. So I'm gonna do a quick assert in our thing here. We're gonna go into debug mode. We're gonna go to our terrain callback here, and we're just gonna assert that ev.normal y is greater than 0.0f. And that should always be the case, because based on how the terrain works, it's impossible to have, like, a face facing downward. All faces are, by definition, facing upward. So, if this is below 0, then something is wrong, and I think we need to flip the normal. I mean, I think it has to do with this weird hack that I had to do here. So we'll wait for that to compile. But we might just be able to do, if this is less than 0, flip the normal upside down. Yeah, immediately. We're getting contact events that have a negative contact normal here. So, I'm just going to see how's this happening here. This is going from handle new contacts. We have object A. Wait, we have object... Okay, so object A. Oh, my bad. My bad. The contact normal is on the other object. So it should be... I think it should be like that, actually. So it should be less than 0. That seems right. I don't know. We'll see. We'll see. It should only ever be one of them. If you know what I'm saying, right? Like, basically, this is the direction that the hit is coming from. It should be less than 0, not greater than 0. Because we do this here. All right. Okay, so that's not happening here. But then what happens if I put in Behemoth? Because Behemoth was where we were seeing the issue. So. Oh, that's coming in fine. Oh, shit. Yeah, I don't know. That seemed to work. I guess maybe the velocity's not high enough. So let's do energy divided by 750. Also, the velocity randomness. So I'm going to change this into a vector quantity instead of a instead of just like mixing the two things. We'll do 80% of the x, 90% of the y for the randomness, and 80% of the z. Then we'll copy this. Why are you having an issue there? We should just be able to copy. Why can't we add to... Okay, we can. Okay, so that's going to be 0.2, that's going to be 0.1, and that's going to be 0.2. And that should, like, sort of limit the vertical, if you will. So, also maybe we'll do velocity randomness dot y is equal to absolute value of velocity randomness dot y. just to make sure that it it's always, oh, it should always be going up. So that's, so what we should do is, actually, the negative only applies to that now. Oh, wait. So the negative applies to the normal, but not to the velocity randomness. Okay, cool. So let's try that. So higher energy, we're doing less, yeah, let's try that. Because I just feel like Behemoth falling should kick up like a lot of dust, you know what I'm saying? You know what I'm saying. Alright, so waiting on that to go. Alright. Gonna drop in Behemoth right here. We should get rid of the music there. Also, maybe this should be in release mode instead of debug mode, but let's get our Behemoth. Okay, we got a little bit of dust, but not enough. Let's see what happens with Leviathan, just because, like, you know, that I'm gonna go back to release mode, because we don't need this in debug mode right now. Yeah. I don't know. This is gonna require some tweaking off stream, I think. Just to get it just right, you know what I'm saying? You know what I'm saying? Yeah, don't forget, if you're watching, it's your first time, or even not, if you're not part of the Discord, you should be. The Discord is, we have all sorts of discussions, and we do playtests through the Discord, so if you want to playtest the game, you should join the Discord. Yeah. And wishlist the game on Steam as well, which is really important, if you haven't done that yet. The game is a short Odyssey, and there's a link to the Steam page below if you wanna get in on that. Alright. I'm just waiting for this to compile now. Okay, we got that. All right, we're gonna go see Leviathan and see if he crits the particles that we're looking for. So, we'll grab a sword. We're gonna go check out Leviathan. He's over here. We got our oh, where'd our impact sound go? I thought we were gonna have an impact sound when that happened. One second. I'm gonna tweak something real quick, which is the threshold for the impact sound for terrain. Because I feel like it's impact sound threshold 1. Save. I feel like it's not triggering when it should be. Like, I feel like Leviathan should be triggering impact sounds all over the place when he hits the ground. Because he was doing it when I was testing it yesterday. I mean, that's what you'd expect here, but, like, what happens with Leviathan? There we go, we had a sound. But we didn't get dust. Why didn't we get dust? Let's see if there's dust happening in wireframe. I mean, that's dust from the explosion. That's actually separate dust. Okay, we did get dust, but it's going straight down, eh? It's just going straight down. It's like barely... So something's wrong here. Something really is wrong. Maybe my calculation here? So the rotation... Okay, so add velocity, normal, which is the contact normal. Let's put a breakpoint in here. Can we look at the contact normal? Okay. Yeah, it's like basically directly negative, and so -1 is 1, which should be going up, right? The velocity should be going up. Maybe the energy's not high enough? Ooh. Ooh, this is interesting. Ah, this guy needs to be... This is maxing out at 10. Maybe we need to max out at 50 and also increase the, decrease the divisor. So, like, I don't know, like 500? Let's try that. Maybe we should get some more shit going on here. I don't know. Yeah. Just wait for this to compile again. Really gotta factor out this, like, stuff into its own, like, class or whatever. Gotta put it in its own file so it's like compiles quicker. You know, actually, we could do that. I wonder if that would speed up compile time. Okay, Leviathan, come at me. We'll see what you do. Okay, that's fine. Come on. Come at me. Okay, I didn't see... Okay, the particles are still going straight down. What is wrong with you, man? I mean, it could be that they're too heavy. Yeah, so like we're getting... Okay, this is gonna be some tweaking. This is gonna be endless tweaking, I guess. A lot of tweaking. Because like we're getting particles, they're just not going in places that we can see them, you know what I'm saying? What if it's not the contact normal they should use, but what if it's the terrain normal that they should use? So, what I need to do is, can I get the normal on the terrain? Let's take a look at, this is in Plant Spawner that I do this. I take the normal from the terrain. Okay. Calc normal. Ah, okay, cool. So, ooh, what's normal scaling? Ah. Okay, so... Let's try that. Let's get our normal scaling. And we're going to, come on. We're going to calc our normal, which is going to be that. And terrain dot. We also need to figure out what our terrain texel is. Yeah. So world to pixel. Our world is, our world position is ev.position. That's going to calculate the normal at that position. Then, instead of negative EV normal, we'll just use our terrain normal. And maybe that'll be more reasonable. Yeah. Yeah, so we're going to ignore the normal on the other object and just use the normal on the terrain. And we're going to calculate that, like, manually, basically. It should be a lot more consistent, I think, hopefully. So, that's going around. That's working. So, I'll take my barrel here. Let's drop it, see what happens here. Okay. That seems actually like that might be better. Let's try here, where there's less grass. Yeah, okay. What does Leviathan do now? It might literally just be the contact normal was screwing shit up. So let's make him charge at us. No? Okay. Maybe that's not it? Yes. I mean, the reflection is making it look a little bit weird. But, like... Because you see those dust particles are going below the terrain, right? Okay. We got particles, but they're not... Oh! Oh, I see we're spawning too many particles. Okay. So, we're gonna need to do a couple things. I'm gonna take my particles, my grass particles, and my dust particle 256. Maybe we need more of them. I mean, actually, let's just maybe because we're only spawning up to 10. Maybe this is gonna be better. But like, yeah, we're doing like up like maximum 1/10 the particles. So that should maybe make it, because like basically what's happening is that we're spawning so many particles that we're like hitting the particle limit, and it's like replacing the old particles with new particles that are like, you know, non-existent. Like they're just spawning, so like it's basically they haven't moved away, so you're not seeing the explosion. Yeah, so those are actually creating a lot of particles. So many particles, it's making the particles disappear because they're spawning them too quickly. Does that make sense? So if we limit the number of particles, that should be better. I don't know. This is just my thinking. Alright. Come on. Come on. Come on. Okay. Guy, come at me. Alright, that's fine. That's fine. Okay, what's going on here? Okay, we're still popping out too many... Something... Where are my particles? Where are my friggin' particles? Alright, let's see. I don't know. I don't know what's going on here. Do you have an IK solver for the dragon, Mr. Indie Music 101? It's not IK. I do have an IK solver. But the dragon's... I mean... The dragon's using, I mean, technically he's not a dragon, he's a Leviathan. But anyway. He's basically using a chain of rigid bodies. So it's like, it actually has collision and shit like that. He's using constraints. Yeah. That's how it's working. So, like, I'll show you in a second. I'll show you right now. Basically, the way it works is that we have our Leviathan here. And Leviathan is actually made up of a bunch of these different segments, right? And, so we basically set where his head is, and then physics does the rest. So you can see there's a point constraint component on this guy, and this point constraint basically constrains him to the next guy in the chain, which is this guy here. So this guy, you can see 115. So we click on this one. This is 115, which is the next guy. So it's like a chain of rigid bodies. And that's what makes the Leviathan tick. But, for some reason, he's not setting off the particles. I mean, these ones are coming in, but like when he actually impacts the ground here, right. Okay, he made a sound, but I'm not seeing any particles. So we go to wireframe, we'll go free camera. Oh. They're all the way down here. Or maybe those are particles from before. So, yeah, okay, so there's some here. But they're getting tripped up. So what I think I need to do is... I mean, just to, like, to test my sanity here. I'm gonna do dust particles. We're gonna do max dust particles equals like some huge number. 10,000. Just to see if that helps. Like, we probably don't want to do 10,000 in-game, but like, just to test my sanity that this is the problem. That it's too many particles being spawned. Because basically, I put a limit on the number of particles for, like, basically performance reasons. And so if I basically need to figure out how to do this with fewer particles. So, I mean, I might, like, spawn, like, larger particles, maybe? Like, fewer larger particles, maybe that might help. I don't know. I'm thinking. So waiting for that to compile. One more thing I haven't plugged yet is the Ko-Fi. So if you enjoy what I'm doing and you want to help support me, because this is my only job, and so I can buy new hard drives and stuff to deal with video editing and all that, I have a link below to my Ko-Fi if you want to send a small donation. Usually $5 or $10 is kind of like what I... But, you know, it's completely optional. It's completely optional. This content is free. So you can just watch it if you want. All right, so let's see what's happening. We now have a limit of 10,000 particles. There we go! There's all the particles that I wanted. Okay, I'm not crazy. We were just spawning too many of them. So, ouch. Yeah, so I think the particles are not big enough. There's too many of them, and they're not big enough. So, dust particles dot scale. What's it set to now? I think it's probably set to like 0.4. Let's do like a whole 1.0 situation here, and make them really grow. Like 1 meter dust particles. Like that might be. We might need to like segment them to like be slightly different values, but let's see what happens here. Huge ass dust particles. A meter in size. That might be too big. We'll see. That's diameter, I believe. A meter in diameter. So I'm just gonna keep going here. So I went shopping for notebooks the other day because I need them for math. Basically, I have this. This is a Star Trek. This is my old notebook. Somebody gave this to me. It's a Star Trek branded grid paper notebook, and you can see all my random vector stuff that whatever I was doing for the game. Doing some diagrams and shit like that. Anyway. I got a bunch more graph paper notebooks, empty, so I can do all my math and stuff like that. I'm very bad at showing things off to the camera. That probably was very non-professionally done. So let's do. All right, let's see. First of all, what this looks like with the huge dust particles. Pretty big. I mean, I do think that actually looks better. It really does look not bad. Yeah, so we're probably spawning too many of them. Like, definitely. So I think we're gonna unmute that. So, go back into this. It looks better, yeah. But there's probably too many of them now. So I need to set. So the energy level over 750. I'm gonna do energy level over. So I'm gonna make this like grow over 5,000. Great. I think that's gonna make a lot more sense. So basically anything under 5,000 joules is going to spawn one particle. And then for every additional 5,000 joules is going to spawn another particle. Basically. This is, by the way, this is the first time I've ever used the unit joule, like, for any reason, like, practically. And I'm really excited about that. Because, like, it's an interest... It's a unit of energy. Joules are cool. Joules are cool. Alright, let's... Okay, drop the barrel again. I realize we're like, this entire stream is like me dropping barrels, but like, you know. It is what it is. Yeah, so I think that was basically just one particle. Although, it's definitely more than one. Why is it... This might explain what's going on here, because we're hitting the... Do we need, like... Was that one particle or two particles? That's like 3 particles. Okay. What's going on here? What's going on here? So we got 4th... this seems wrong. This seems wrong. Okay, go into debug mode. Go into debug mode. Long stream today. It's fine though. I feel like YouTube wants me to do longer streams because everybody tunes in like halfway through the stream apparently, and which is fine. Like, I mean, so now if I just do a longer stream, people will see more of the stream. Seems to be working. Also, you know, I am like actually trying to figure out this, and it is taking me longer than I thought it would. So I'm just gonna stream for longer until I figure it out. Yeah, we've been streaming for like 3 hours now. By the way, you don't have to watch the whole thing. Like, if you have something to do, you don't have to like be locked in watching me all day. Like, while I figure this out, it's up to you guys. You can watch as long as you still find it entertaining, or educational, or both. Okay, so what's going on here? Okay, what is this impact here? Energy level. Ooh. The energy level is 20. Where's that impact coming from? That's curious. So. Okay, we're getting a lot of impacts here. Where are they from? Energy. 101. That's interesting. That's interesting. Oh. One thing we should also do to just cut down on the number of particles that are spawned is literally just do this distance check here. By the way, so like obviously this is like it's like an open world game. Like you can like you can like go anywhere at any time, and there's not like segments. So like this distance check thing needs to be used all over the place because you could be spawning stuff on like the other side of the world. I'm gonna do this at 500. Basically, also I'm gonna do this as renderer. Renderer, active renderer dot get camera dot position dot center. There we go. So if we're more than like if we're more than a certain distance from the camera, we just don't do this, which should cut down on some of that. But we are still getting more particles than I thought, because it should be only... Like, unless we have a ton of energy, we should only be doing it at... like a small number. You know what I'm saying? I don't know. All right, let's mute Kevin McLeod there for a minute. All right. People are still watching, so I'll keep streaming. All right, what's going on with this guy? Okay, so we're not getting as many random impacts because I limited the thing here, but what's gonna go? Okay, what's this guy? Why are we getting these? Where are these impacts coming from? Okay, I wanted that impact, but that was at 66. It could be that it created like a bunch of contact points? A bunch of additional contact points? Oh my god, what's going on? Game is... Oh yeah, we gotta show what's going on with my debugger here. Yeah. So, energy, 77. Energy level is 0.1, which should be clamped in between 1 and, okay, interesting. 78, energy level is, okay. So are these just like a bunch of like recurring impacts? Do I need to set some kind of like last particle spawn time or something like that? So here's what I'll do. I'll do the same trick that I did for the other guy, and I'll get our music back. 1 second. Where'd my music go? I accidentally closed the window. Oh no, it's actually here. We're back to the beginning of the playlist. Great. Okay, cool. So, so I have my last trigger time. Right now, I'm gonna do a just to test, because like this is bad form. This should be like in the entity. We should do static code time point last particle spawn time equals or just default, and then we'll do like a literally just copy this and then I'll make that 33 milliseconds, let's say. It can be smaller than the audio one, and then we need to set last particle spawn time to game time, and then that should further limit the number of particles. I mean, maybe too much, because like technically there could be multiple impacts. I don't know. I'll have to like think about it. I'll have to think about it a little bit more. It can have like a max number of particles per frame or something like that. Yeah. Okay. Let's mute that. Let's get our barrel. This should spawn 1 particle. It spawned no particles. That's a problem. Or did it? Did it spawn no particles? Wireframe. Okay, that's a problem. Maybe that thing's not being initialized correctly. We got, what's this guy initialized to in, last trigger time? What are you? Code time point, yeah. What's our, what's going on now? Okay, so we do get past this. But why are you not spawning anything? Okay, let's go back to the other barrel. Like, I'm wondering if it's like a barrel specific thing. We got my character selected? Okay, something weird is going on here. Oh, it might just be that it's wireframe. Yeah. Okay, let's try this guy. Is this barrel any different? Are they different? No, that guy's not spawning any particles either. Why not? Okay. Okay, that's interesting. That's quite interesting. The only thing I changed was the spawn time. The distance? Okay, this is getting triggered. But the energy is never below. What's the energy here? 0.0 something, yeah. The energy's never above 10. Why is that? Oh, this got energy above 10. And that did it spawn particles? Yeah, it even spawned particles. Where is it? That is definitely above 10. Where are my particles? Why are you not spawning them? They get really tall. We didn't hit that. Clamp energy level to 1. Ah. Is it this thing? How could it be this thing? Okay. Last particle. Oh! This needs to be in here. My bad. My bad. It actually needs to actually spawn the particle. That's it. Okay. It needs to be inside the if statement. Alright. Let's compile that one more time. Okay, we're gonna take that out. Alright. Let's take our friggin' barrel. Okay. Drop. Nice! One particle. One particle. And it... Okay, so now... We'll go back to release mode. And do it at full speed and see what happens. Hmm. Yeah, I'm gonna need to, after this, I'm gonna need to, like, take a deep think about what the hell's going on here. Still compiling, still compiling. Alright, here we go. Crysis 4. Starting up now. Okay, so. Drop the barrel. At full speed. That's... I mean, we probably need to spawn, like, 3, but I was just, like, testing this. Alright, Leviathan, what do you look like now? What does Leviathan look like here? Coming at me. Alright. So, let's see what happens when he hits the ground. What? Ah. Okay, come on, come at me, come at me. Maybe it's spawning the particles that are, like, not ideal, you know what I mean? Like, because I limited it, it's... Yeah, they're going straight fucking down. I don't understand it. I don't understand it. Alright, I don't know. I don't know what the hell's going on. I guess we could just, like... Let's... I'm gonna get rid of this. I'm gonna get rid of this. I don't know. It was looking fine before. We're just gonna leave it like this. We're gonna leave it like this. 10,000 particles. I know it's a lot. And deal with it, I guess. I don't know. And then we'll call it a day. And then I'll look at this after off stream and see what the hell's actually going on. Yeah, I mean, I don't mean to end this, because I think we're probably going to end the stream in just a second. Like, I don't want to end it, because it's been 3 hours. I don't want to end it on such a downer note. So what can we do? I mean, we'll just see what it looks like. Let's just cut some trees down and just see all the stuff, because I think the trees being cut down actually look pretty good. The trees being cut down look all right. So, let's grab this guy, cut down a tree, and see what it looks like. Crysis 4, right here. You can wishlist it on Steam today. It's actually called A Short Odyssey. It's not called Crysis 4. That looks pretty good. I think that looks pretty good, and let's cut down this guy too. Maybe a bit aggressive. Yeah, you know. Alright, what does Behemoth look like? Let's... Behemoth, what do you look like? Actually, it's in here. Alright, Ragdoll. Kick up some dust. There we go. Yeah, the velocities probably need to be adjusted. But, there we go. We got Ragdoll. I feel like he should make some more noise when he hits the ground, but... oh, that's not the one. Behemoth Ragdoll. Let's put another one down here right next to us. I don't know why he's not making sound when he hits the ground. Behemoth Ragdoll. Oh, he did. There. I guess the energy of the contact is not enough. What if I'm right next to it? Where's that sound? Alright, terrain? Impact sound. Let's do 0. I don't know. We're messing with this guy. It's... Let's cut down a tree. Call it a day. Thanks for watching, everybody. And we got our little grass particles, too. We got our grass particles. We got our dust particles. I think it's looking good. I think it's starting to look good. Anyway. This has been the stream. The game has been a short Odyssey. Thank you all for watching. I am gonna head out, but thanks for tuning in. Do not forget to wishlist the game on Steam. Like and subscribe. Join the Discord if you're interested in maybe doing a playtest or just want to talk about the game. And if you want to help support me financially, there is a link to my Ko-Fi down below where you can give me a small donation, $2, $5, or $10, so that I can buy new hard drives and stuff like that, so I can fit all these videos on it. Thank you, and I will see you guys next time, Thursday at 11 a.m. All right, 11 a.m. Eastern Standard Time. All right.